Welcome back to digital class, and now we are looking at our PSLE last minute revision, and this is set number B. So let's start off with the first question here from CHS paper 1 question 15. So let's look at this question. Here say that Joe baked some chocolate muffin and vanilla muffin. He sold an equal number of chocolate and vanilla muffins. He had 3 out of 4 of the vanilla and 3 out of 7 of the chocolate muffin left. What fraction of the muffins was sold? So the first thing that when you look at this question, and you should know immediately what concept is this. This is equal concept and common numerator. Okay, type 1. So if you have been looking at our booklet, revised using our booklet, you should know this concept well. Okay, so let's try to write it down. Okay, the keyword here is that equal number of chocolate and vanilla muffin. And again, sold. Now look at here. I have chocolate, I have vanilla. Chocolate, I have 3 out of 4 vanilla. So I have 3 out of 4 vanilla left. And I have 3 out of 7 of the chocolate left. But what is important here is that what is equal is actually the sold part, is the selling part. So if I have 3 out of 7 left, I have how many sold? 4 out of 7. If I have 3 out of 4 left, means I have 1 out of 4 sold. And again, the numerator part, this part and this part are the one that's supposed to be the same. Huh? Teacher, why is not the denominator? Because we always make the denominator the same. Yes. That is additional of fraction, but this is not about those normal operations of fraction that we are doing. Okay, so this up here represent what we sold, and down here represent the total number of either chocolate muffin or vanilla muffin. Okay, so this one you are supposed to make it the same. Why? Because equal. Okay, these two are supposed to be the same. And we times 4 here, and I know here become 4 out of 16. Okay, and again, this 4 and this 4 represent what? The muffin that we actually sold. And now they're asking, right? So sold will be 4 plus 4, which is 8. Because we are now looking for the fraction, so we need to find the total also. Total, I have 7 unit of chocolate muffin and 16 unit of vanilla muffin. So it's 23. That's why fraction means 8 out of 23. And the answer here is option number 2. Okay, because 8 out of 23. Okay, so again, nothing tricky here. The reason why I'm choosing this question is just to revise this concept, because again, some of you still confused with this concept. Okay, let's move on to our next part. And the next question is from ACSJ paper 1 question 15. Now here say Molly had a container full of flour. Okay, Nelly and Ollie each had 2 over 7 of what Molly had. Molly gave away some flour to Nelly and Ollie so that 3 of them have the same amount of flour in the end. What fraction of the flour did Molly give away? So let's try to draw M and O and just put this into a big idea. M and O. M and O. Here's Nelly and Ollie each had 2 out of 7 of what Molly had. Means that if Molly have 7 unit, Nelly and Ollie actually, or N and O actually have 2 unit, 2 unit. Does it make sense? 2 out of 7, right? 2 out of 7. Now, what happened here, say, is Molly gave away some flour, gave away something here. I don't know how many. So that 3 of them have the same amount of flour in the end. Now, a very important concept here is that when M is giving something to N and O, what actually still supposed to be the same? The total is still supposed to be the same, right? So what I can actually kind of notice here is I want to make this to be equal. I need to make these 3 to be equal. That's why I want to be the same fla in the end, right? So what I can do instead is just do 7 plus 2 plus 2. And I want this to be divisible, means that I'm able to be divided by 3. So 11 cannot divide by 3, right? So what can I do is I can make it 3 times. So 11 times 3. So become 33. So what I do is I times 3 times 3 times 3. And now this is 21 unit, 6 unit, 6 unit. Again, I'm able to do this because this is not an exact number. It's just a unit. Okay. And now, and I know each of this supposed to be what? 11 unit, 11 unit, 11 unit. Correct. Because in order to be equal, same amount, so 11, 11, 11. So 21, I need to give up how many to become 11? I mean, very obviously, it's 10. So I know here will be plus 5, right? Here will be plus 5. So it'll be 11, 11. So means that Molly need to give 10 unit out of the 21 unit that she or he has. Okay. So what fraction of flour did Molly give away? 10 out of 21. Again, 10 out of 21 that she has or he has. Okay. So 10 out of 21, the answer is option number 4. Okay. Yes. Good. Okay, let's move on to our next question. Our next question is from ACSJ, paper 1, question 26. Again, this is not a tricky question, but I'm choosing this question because I want to quickly revise the concept of direction. Okay. So here, you need to find the square grid shows the plan of a playground. The rocking horse is north of the seesaw. Now, if you notice this question, right, they did not give you something usual. No, usually they will give you something like this, right? But this question is not giving you this, but rather it gives you a statement here. So here says what? The rocking horse, which is here, is north of seesaw. Means that, again, if you see the word north of seesaw, means that from the seesaw side, going to rocking horse is north. So it means that this going up is north. So basically, it's the same thing that the direction be like this. This is north. Okay, and this statement can be very important because I can change, right? I can change to become the seesaw is north of rocking horse. Then it will be like this already. This is north already. Then where is east? Then east supposed to be here, but in this case it will be here already. So again, this statement can actually be very, very important. And if I were to be tricky, I would definitely change this to not be like this and either be like going down or going to this side to make it more confusing, right? Okay, to test your knowledge. But anyway, this question is very kind, so let's not think too much. Here, in which direction is rocking horse from swing? Again, from. So you need to look for swing first. Swing is here. Going to this direction. So it's going to what side? East, right? So east. So part A, question A is east. Okay, you can write yourself here, but I'm just saving some space. B, let's look at this question B. The playground manager wants to place a bench in the playground. Okay, this bench is placed south of the slide. Slide is here, right? South means where? Means either here or here, right? And not northwest of roundabout. Roundabout is here. Northwest is where? Again, north, east, west, south. Northwest will be this direction. So it will be here. Put a cross in the square where the bench should be placed. So, I mean, I know, right? The only spot that matches these two requirements is this box. So again, please be careful. Don't put other tick there to confuse. Just put X according to the instruction here. If you're drawing something else, right, you just remove it, okay? Just to be safe. Okay, just remove it. Okay, just make sure that you have whatever you need only. Yes, and that's it. That is basically the question. Simple and easy. Okay. Let's move on to our next question. Our next question is from ACSJ, paper 1, question 26. I don't think so. Okay, I think this is put wrongly. This is from 2025, P6, CHS. Yes, paper 2, question 4. Okay, I think this is the question. Sorry for the mistake, but let's look at this question. This question is not a very difficult question, but I'll say that it's an interesting question for you to kind of take a look. Look at here, okay? Here it says that figure 1 is a triangle, as you can see, it's a triangle with a perimeter of 39 cm. Each side of the triangle has different design. So as you can see, this side have the moon, this side have a heart shape, this side have a sun, and figure 2 is made up of 5 such triangles. So it use one of the side and go and connect, or two of the sides connect. And the perimeter of figure 2 is 87 cm. What's the length of ST in figure 1? So this part. So I think one of the easier way, if you are not the person that are very good in spatial kind of imagination, probably the best way is you put alphabet or put numbers or put color or whatever. Example, I will actually put this as A, I put this as B, I put this as C. So whatever moon, I will just put A. So I'll just put here A moon, A moon, A moon. So I'm not putting here because it's connected. So it's not part of the perimeter that we're describing here, okay? So sun will be C. So I'll just put C here, C here, C here. And the heart shape, I'll put B. And the heart shape here is B. Okay, perhaps what I'm looking now, ST is B. Okay. And now if you try to put it alphabetically nicely, figure 2, I know is 87 cm. And this figure 2 have what? A, I have A, and A, 3, yes. And B, I have only 1. C, I have 3, so C, C, C. And figure 1, I have A, B, C, okay? A, B, C. So, and that is actually 39 cm. 39 cm. So if I choose to use figure 2 to minus figure 1, means 87 minus 39. Let's just try to write 87 minus 39. And that should give me 48. And if I just minus, I will left with what? B, B, C, C. I will left with 2A and 2C. Means that 2A and 2C will be equal to 48. If I want to look for only A and C, means I need to divide by what? 2. So 48. 2 divide by 2, divide by 2, divide by 2, it will be 24. And I think it's kind of obvious now. I'm now looking for what? ST. ST is actually what? ST is actually B. I know A plus B plus C is 39. I know A plus C is 24. So if I use 39 minus 24, which is ABC minus AC, I will left with what? B, which is ST. Okay? So my next step is to use B, which is 39 minus 24. Because here is ABC, this is AC. So I minus away AC, we left with B. So B is 39 minus 24 is equal to 15. Yes. And this B basically is ST. I mean, of course, if you are not, if you feel this is confusing even more, then you don't use this method. You just use whatever method that you think is more suitable. Okay? Because I think if I have to describe it in the space, kind of spatial way now, through the screen, I think it's a bit hard. That's why I just put labeling A, B, C here to help you better. Okay? So let's move on to our next question. Our next question will be I-Tong paper 2 question 15. Okay, paper 2 question 15. Now, this question here says that Selvi used rods to form figures that follow a pattern. So the first 4 figures are shown here. As you can see, figure 1, 7, figure 2, 10, figure 3, 12, figure 4, 15. And the question here asks is, what is the difference between the number of rods used for figure 7 and figure 9? So basically, I need to find 7 and 9. And what I will always suggest students or you guys to do is try to add one or two more lah, just to make it nicer. Okay. So you can see plus 3, plus 2, plus 3. I mean, hopefully next one is what? Plus 2, right? Because it's like 1, 2, 3, then 1, 2. 1, 2, 3, then you next one be 1, 2. So here will be probably 17. Okay. And if you would like to, because it's like plus 3, plus 2, plus 3, plus 2, it's a bit hard to kind of guess, right? So another easier way for you to think about it is like this. Here, go here, means that all the odd number, here, 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 will actually plus 5. Here, will actually plus 5. And the next part of the question says what? What is the difference between the number of rods used for 7 and 9? And you know, right, 7 and 9 is another odd number. So the increasing part for 7 to 9, it of course will be what? 5. It will be the same. So here is 5. So nothing tricky lah, okay? Nothing tricky here. Okay, next question. How many rods would she use for figure 99? I mean, 99 again is an odd number. And you know that odd number will be a kind of a plus 5 trend, right? But how many plus 5 that would you need to have? And that is something that a bit confusing now. Okay, so let's try to really sound first. 1, 3, 5, 7, 9. Then 11, 13, 15, 17, 19. Then you'll be like 21, 23, 25, 27, 29, right? Then it will be continue until 99. So how many plus 5 do I need to have? How many plus 5 do I need to have? So first thing, I know I have 1, 2, 3, 4. Look at here. I have 1, 2, 3, 4. So one row, I need to plus 5 for how many times? 4 times. Okay. And how many rows will I have? 1, 2, 3, 4 are supposed to be actually 10 rows, right? The first row here, second row here, third row here. So up to here will be the 10 row. So it means that I will have plus 5 in each row for 10 times. So it'll be 40 times I need to plus. Okay, but is it done? No. Because 9 to become 11, I also need to plus 5. Okay? And like this, I need to plus how many times? Like 1 to 2, 2 to 3, 3 to 4, 4 to 5. I need to actually have 9 times. So it's actually 49 times I need to plus 5. Again, how do I know? Because here, because 1 to 2 is 1 time, right? 2 to 3 is another time. So if you try it out until 10, it will be 9 times. Okay? So in conclusion, I need to plus 49 for 5 times. Right? Plus 5 for 49 times. Okay? So again, I start with number 7. I need to plus 5 for 49 times. Just press on your calculator and you should get 7 plus 2, 4, 5. And that will be 252. And that will be the final answer. Okay? So again, let me just quickly explain again. I feel that I might explain it not that clear. So now, what I'm trying to do now is to find figure 99. Means that I know this is an odd number, so I know that every time from the first to the third number is plus 5. So if I were to arrange 1 to 9, 11 to 19, I know each row I need to add 5 for how many times? 1, 2, 3, 4. 4 times. And I know I have 10 rows up to 99 here. It will be 10 rows. So I times 10. So I know it's 40. And each row, there's a connection, right? From 9 to 11. So I need to plus 5 here also. So this will go on for 9 times. That's why I plus 9. So 49 times. So 7, the original number here, I need to plus 5 for how many times? 49. That's why I get 252 in the end. And that is the answer. Okay, this will be kind of a bit interesting question. This is not a very common question that we actually see. But anyway, it's a good question for us to try it out. Now, let's try our last question for this set number B. And this question is from ACSJ, paper 2, question 17. Okay, let's look at this question together. And fill some oranges into a large and small bottle. So I have a large and small bottles. Now, she filled 3 out of 5 of the oranges into 4 large bottles and 3 out of 4 of the remaining oranges into 9 small bottles. What fraction of the oranges was filled into 9 small bottles? I mean, perhaps it's good for us to draw a model. Let's just simply draw a model like this first. Okay. Now, she filled 3 out of 5 of the oranges into 4 large bottles. So let's just cut into 5 parts. 1, 2, 3, 4. Let's just add on another one, 5. This 3 is filled with what? 4 large bottles. So 4 large bottle. And 3 out of 4 of the remaining, here say what? My remaining is 4. But here say my remaining is 2. So as you know, we need to cut into 2 parts. So 3 here, I can fit in 9 small bottles. Okay? And this one is what I left. Question. What fraction of the orange juice was filled into 9 small bottles? 9 small bottles basically means this. So 3 out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the answer is 3 out of 10. Okay? Now, let's look at the next part of the question. It's a bit confusing, seems like. After that, she wanted to fill 1 large bottle with the leftover oranges. Leftover oranges is here, right? Leftover oranges. Okay? But was short of 0.6 liter. So instead, she filled another 1 small bottle and had 0.8 liter of the orange juice left in the end. So how many liters of orange juice did Anne have at first? So let's try to write down everything nicely first, okay? 1 large bottle, 1 large bottle. She want to fill it with leftover oranges. Means that leftover oranges. So this one, you can see the blue color part. So I'll just label here as blue color. This is the leftover one. Okay. She want to fill, but it was short of 0.6. This basically tells you that whatever left now is not enough to fill in 1 large bottle, correct? Short of 0.6 liter means that I need extra 0.6 liter in order to fill in 1 large bottle. Okay? Let me just label here again. This is what I left. I repeat, whatever I left now, I want to fill into 1 large bottle. But it's not enough. It's short of 0.6. So I'm adding 0.6 here so that it's enough to fill in 1 large bottle. Okay? Let's continue. So instead, she filled another 1 small bottle, means that this leftover. Now let's fit in another 1 small bottle and have 0.8 liter of orange juice left in the end. Oh, means that this one, if I fill into small one, means that if I cut this into small, here I still have actually 0.8 liter left. Means that this leftover is enough for 1 small one and have extra 0.8. So this is basically the pictures that you can kind of see and imagine out here. So now, what can we do next? I mean, of course, there are many methods to continue this part, but let's try to use this part, okay? So let me bring this out. Okay, let me just bring this part and put it here. Okay, now what I left is actually 1 unit, right? So this is actually 3 unit. So what I want to do now, a bit confusing maybe, but this is what I thought of it at first, is that I have this 3, correct? This will be the 9 small bottles. I cut, right? Because this is 1 unit. So I actually can cut into like this. Let me just cut out. Small, 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 and this is 0.8, 0.8, 0.8. I'm not sure whether you can understand or not. Let me just remove it again. Let me just draw again. I have 3 unit here. This is where I bought from this 3 unit. Okay. And I know each unit actually is 1 small plus 0.8. Means that I actually can cut 1 small 0.8. 1 small 0.8. 1 small 0.8. So actually 9 small water bottle actually equivalent to what? 1, 2, 3. 3 small plus 0.8, 0.8, 0.8, which is 2.4. This basically tells you that 6 small is equal to 2.4 liter, or 1 small is actually equal to 0.4 liter. Okay, that's what we actually found out. And we find out 1 small is 0.4 liter, then I can find out 1 large is equal to what, right? Remember, 1 large is 1 small plus 0.8 plus 0.6. So 1 large, let me just put this L, is 0.4 plus 0.8 plus 0.6. And that is actually 1.8 liter. So now you can actually see very clearly that 1 small give you 0.4 liter, 1 large give you 1.8 liter. Okay. Next part. The question now asking how many liters of orange juice did Anne have at first? So this will be the part that we now need to look at. Okay. 1, 2, okay, basically 4 large bottle. So 4 large plus 9 small plus left. And left, let's look at here. This left, now is this left also, right? It's actually 1 small plus 0.8. 1 small plus 0.8. So, or I can also say it's actually 10 small, right? So 4 large, so 4 times 1.8. 10 small, so 10 times 0.4 plus 0.8. So if you put in your calculator, you should get 7.2 plus 4 plus 0.8. And your final answer should give you 12. Okay? And your answer here is 12 liter. Okay, there's a bit confusing maybe, but let's try this out. I think you can actually understand this. Okay? I mean, of course, there are many methods. Like if you want to go through the large bottles, also can. You go through the small one, also can. It doesn't really matter. Okay, and we are done for this question 17 from ACSJ. Okay, and if I'm not mistaken, this is perhaps the last question for our set number B. Yes. Okay, again, I hope you are actually able to learn something throughout this set B revision. And again, all these questions are kind of interesting and perhaps it's actually very useful for us to revise. And I really, really hope that you can revise again, not only through this video, but also through your own revision with different questions. Okay. Anyway, thank you. See you. Bye bye.